Now the topic of discussion is 8259A programmable interrupt controller. Now as we know, we have studied the interrupt which are related with the 8085, and because of the limitation that they have a limited number of pins available for any input output device to interrupt the microprocessor. So we are in requirement of a hardware so that the interrupt priority can be managed, as well as if number of input output devices wants to interrupt microprocessor operation for transferring of the data, it can also be managed. So 8259 is a programmable interrupt managing device, you can say, specifically designed for the use with the interrupt signal, that is INTR line of 8085, and it has certain features which provide the facility of maintaining the priorities among the different input output devices which wants to interrupt, as well as providing more facility so that more devices can interrupt the 8085 operations for transferring of the data. So as far as the features of this programmable interrupt controller is concerned, it is an integrated chip having 28 pins. It has the capability to manage 8 interrupt requests at a time, and it also provides an interrupt vector request anywhere in the memory map by the program control without any additional hardware or the restart instruction. And for that particular purpose, it uses all 8 requests which are spaced at the regular interval of either of the 4 locations or of the 8 locations, meaning thereby it is capable of resolving 8 level of interrupt priority in the various mode in which it used to work. The different modes in which it used to work is a fully nested mode, automatic rotation mode, and the specific rotation mode. The fully nested mode is a very simple mode in which it used to work. This is a fully nested mode is a general purpose mode in which all the interrupt requests are arranged from highest to the lowest. The different 8 priority lines, if it is mentioned from IR0 to IR7, so there is a fixed priority which are arranged from highest to lowest. In addition to that, if any interrupt line are assigned the highest priority in this particular mode, the priority sequence will then begin with that particular interrupt line. For example, if IR3 has the highest priority, then if IR3 is the highest priority and IR4 is the lowest priority, then IR3 with the highest, IR4 will be the next. If IR3 is the highest priority and IR2 is the lowest priority, so the fully nested mode will work in such a fashion that IR3 will be the highest, then IR4, then IR5, then 6, 7, then 0, then 1, and then 2. So this is called the fully nested mode. Now the automatic rotation mode. What is automatic rotation mode? In this particular mode, a device, if it is being served by the interrupt controller, since it is being served, it is allotted with the lowest priority. Since it is being served, so next time it will be the lowest priority. So assume that the second interrupt line is being serviced at a particular moment of time. So next, in the next case, that IR2 will be given the lowest priority. That is the automatic rotation priority. Then we have specific rotation. Specific rotation, this mode is similar to automatic rotation, but the user can select the interrupt line for the lowest priority and thus fixing all the rest of the priorities. So since it is capable of maintaining the priorities, so that is why the interrupt controller is more required. Now it is also capable of masking each interrupt line individually. The meaning of this particular thing is that if there are number of lines and if we want that particular lines should not be served, it should be masked. So if any device is connected to that particular line and if that line is masked, that device cannot be entertained by the microprocessor. So it also provides the facility of masking. It also provides the facility by which it can check the status of pending interrupt. What do you mean by pending interrupt? Pending interrupt means if suppose two interrupt lines is going to interrupt the interrupt controller. So the interrupt line which is having the highest priority will be served by the interrupt controller, and the next line will be pending. Okay. At a time it will be handling only one device for the interrupt purpose. So if more than one line is going to interrupt the processor, the interrupt controller, so that will be coming into the pending mode. So once the first line which is being served by the interrupt controller, then it used to check whether any more request, is there any more pending interrupts are there. If it is, then it will handle the priority wise. Along with that, it also have the indication that which line is being served by the in service interrupt, as well as it also used to check the masked interrupt. Now, as I told you that 8259 is capable of handling 8 interrupt lines at a time. So we have the restriction if we are using one interrupt controller. So we have the restriction that we can handle only 8 devices. But if the requirement is that if you want more than 8 devices to be interrupted, the processor functionality, so that to transfer the data. So this can also be achieved by cascading many interrupt controller together. So there is a facility by which we can cascade 8 interrupt controller all together, so that the total capacity of the will be enhanced from 8 to 64, because individual interrupt controller will be providing the services to the 8 interrupt lines. So if 8 are cascaded together, so there will be 64 priorities. And it is also capable of setup with the it also works with the 8085 as well as 8086. So this is the block diagram of 8259 interrupt controller. Now this 8259 interrupt controller has 8 blocks. The blocks are known as the control logic block. Then we have a data bus buffer, we have a read write logic, we have a cascade buffer or the comparator, then we have in service register, priority resolver, interrupt request register, and the interrupt mask register. So we have 8 different blocks. We start with the read write logic. Now read write logic have 4 lines. One is read line, another is write line, and A0 and the chip select line. Now when the A0 is at the logic 0, the controller is selected to write the write the command or read the status. When the A0 is 0, then only it is possible to write a command or read the status, meaning thereby reading and the writing process can be done with the help of 8259 interrupt controller only if A0 is 0. So this chip select line and this A0, this both determines that what is the port address of the controller. Now the second one, let us discuss with the control logic. Now the control logic has 2 pins, you can see, one is INT pin and another is INTA pin. Now INT pin is the output of the 8259 interrupt controller, INTA is incoming pin. This INT pin is connected to the incoming pin of INT line of the microprocessor unit. Whenever a valid interrupt is asserted, this signal goes low and it asserts the microprocessor, gives the information that 8259 wants to interrupt the operation of 8085. And once the 8085 acknowledges this interrupt lines, advises to use the interrupt controller to do the data transfer work, it acknowledges by giving a signal, that is interrupt acknowledge signal, which is input to the 8259A controller. So, this INTA is the acknowledgement line and this INT is to, so this is outgoing line and this is the incoming line. Now, let us discuss the different registers which are used in 8279. The interrupt, this is called interrupt register as well as the priority resolver. Now, the first one is interrupt request register, this one is the interrupt request register. Now, this interrupt request register has 8 input lines from IR0 to IR7. When either of these lines goes high, the requests are stored in the register. Now, the second register is the in-service register. In-service register stores all levels of the interrupt that are currently being served. And the third one is interrupt mask register. Now, this interrupt mask register stores the masking bit of the interrupt line to be masked. जिसको हमको mask करना है, that is stored in this is interrupt mask register. And the last one, the last register is the priority resolver. This priority resolver examines all these 3 registers, in service register, request register as well as this mask register. Or it checks all these 3, examines all these 3 registers and then decides and determines whether the interrupt signal should be sent by the 8279 through this INT line or not. Now, the next building block is the cascade buffer or the comparator. Now, this cascade buffer or the comparator, this block is used to expand the number of interrupt level by cascading 2 or more 8259. The maximum which we can do is the 8. So, this is all about the different building blocks. This is data bus buffer, this is bidirectional buffer, and this data bus buffer is connected to the data bus of the 8085. So, this is all about the building blocks of the 8279 interrupt controller. Now, let us discuss about the interrupt operation of how it works. So, first of all, to implement the interrupt, this is all the functionality which I have already explained. Now, let us go with the interrupt operation. To implement the interrupt enable line, enable flip flop of the microprocessor should be enabled. Then only it is possible to interrupt the 8085 operation through the 8279 interrupt controller. So, it is necessary for if any kind of interrupt operation has to be performed by the 8085, its enable flip flop, interrupt enable flip flop must be implemented. It must be enabled first, and this can be done only by writing a simple instruction EI, and 8279 should be initialized by writing a control word into the control register. So, 2 things we have to do. One is to enable the interrupt flip flop by using EI instruction, and another by writing the control word into the control register. Now, 8259 requires 2 types of control words. The first word is known as initialization command word for setting the proper condition, and second word is the operational command words for setting up the status and the operation as well as the masking the interrupts. So, these 2 control words are required. First is enable instruction and second is to write control words into the control register. Now, how it starts its functionality once 8259A is initialized, the following sequence of event, how it occurs, how it starts. Suppose any IR line has interrupted the 8279. Now how it performs, what it will do. So first of all, interrupt request register stores the request, and then it is the duty of the priority resolver to check that IRR, to check the IRR for the interrupt request, as well as to check interrupt mask register for the masking bit, as well as ISR, that is interrupt service register, the interrupt being served, and it resolves the priority and send the INT high. Meaning thereby, what is the function? If any interrupt line comes to the 8279, it is stored in the IRR. Once it is stored, it is the duty of the priority resolver to check whether ISR bit is set or not, because it may be possible that once when the interrupt request is being received by the 8279, it may be possible that at that time 8279 is serving any interrupt, and for that particular case it has to check the interrupt service register, because whatever interrupt is being served, its bit will be set in the interrupt service register. So first it checks ISR, then it checks the interrupt mask register कि जिस लाइन ने इसको इंटरप्ट किया है उस लाइन, वो लाइन मास्क तो नहीं है. So what it checks all three registers: interrupt service register, interrupt mask register, as well as whether any line in the IRR is high or not. And on the basis of these three, then only it decides whether to send the INT signal to the microprocessor or not. Once it resolves all these things, then only the interrupt signal is sent to the microprocessor. Now microprocessor once receives the interrupt signal, it acknowledges by sending the acknowledge signal to the 8279. Now once this INTA signal is received by the 8279, then corresponding to the bit which has interrupted, that is IRR bit, according to that ISR is going to set, which indicates that what interrupt level is being served, किसको वो सर्व करने जा रहा है, और उसी के corresponding जो IRR की bit set थी उसको वो reset कर देता है, इस बात को बताने के लिए कि जो रिक्वेस्ट आई थी वो एक्सेप्ट कर ली गई है. और तब उसके बाद कॉल इंस्ट्रक्शन एग्जीक्यूट होता है. कौन सा कॉल इंस्ट्रक्शन? जिस लाइन ने इंटरप्ट किया हुआ उस लाइन के करस्पॉन्डिंग एक कॉल इंस्ट्रक्शन है जो कि पहले से मेमोरी में लिखा हुआ है, जिसका काम डेटा को एक्चुअल ट्रांसफ़र करना है. नाउ when the microprocessor decodes the call instruction, it places two more INTA signal on the data bus. And what is that purpose? When the 8259 receives the second INTA, it places the lower order bytes of the call address, because whenever it has to call the call instruction is always followed by two 8-bit address or 16-bit address. One will be the lower byte, another will be the higher byte. So first of all, the lower order bytes of the call address is loaded on the data bus, and when the third INT signal, it places higher order data address bytes on the bus. And this call address is the vector memory location for the interrupt, and this address is placed on in the control register during the initialization. जब हम initialize कर रहे होंगे तो पहले से ये address पहले से वहाँ पे control register में होगा. Now ये अब सर्विस अपना शुरू कर देगा. नाउ व्हाट हैपेंस, द ISR bit is reset either automatically or by a command word that must be issued at the end of the service routine. जब कॉल इंस्ट्रक्शन एग्जीक्यूट होगा और वो ख़त्म हो रहा होगा by and how it will came to know that it is going to end by the return instruction. So what it will do, ISR की जो बिट सेट थी जिसके लिए वो सर्विस दे रहा था वो अपने से रीसेट हो जाएगी, या कमांड वर्ड के थ्रू जैसे ही उसको एंड ऑफ रूटीन मिलेगा वो तब उस केस में रीसेट हो जाएगी. एंड देन व्हाट हैपेंस, द प्रोग्राम सीक्वेंस इज ट्रांसफर्ड टू द मेमोरी लोकेशन स्पेसिफाइड बाय द कॉल इंस्ट्रक्शन. सो दिस इज द वे how 8279 used to work.